Well, hello there. Tonight, we're going to go over some of our basic derivative rules. Knowing these rules will set us up to be able to differentiate any function. And we're going to learn about the chain rule, which will allow us to take all of our knowledge about functions and put them together to take the derivative of a composite function. But let's start with our general derivatives. As we know, derivative means slope. Remember that. Everything we do comes from the limit definition of the derivative. That's where all of this starts. And as you know, we do the algebra over and over again, and eventually patterns start to emerge. And what we end up with are our derivative rules. Now, do you have to memorize these? Well, you're going to use them so often, you can't help it. They'll become second nature to you. And you know what? Some of them you already know. For example, what's the derivative of a constant? Well, what do you mean by that? Well, if I give you a horizontal line, say y equals 5, what's the slope of that line? That's right, 0. It's a horizontal line. And in fact, any constant is a horizontal line, right? That's right. So the derivative with respect to x of any constant k is 0. Oh, that's right. How about a linear function? Well, you've been doing these since middle school. What's the slope of y equals 3x minus 5? That's right, 3. What's the slope of y equals 1/2 x minus 4? That's right, 1/2. So in other words, it's the derivative with respect to x of some constant times x. And it's that constant, it's whatever the slope is. Okay, now, the big one we had here is our power rule. This allows us to differentiate any polynomial function. For example, if we have the derivative with respect to x of x to the n power. So let's see, the derivative of x squared, that's right, 2x. How about x cubed? That's right, 3x squared. 3x squared. You see, you do these enough and a pattern starts to emerge. And that pattern is nx to the n minus 1. That's your power rule. That's going to bring us almost everywhere. Okay? Then we have the general constant. For example, if I have the derivative with respect to x of k f of x. Well, I know the derivative of f of x is f prime, and that k just stays with it. And you can think of this as from a variety of ways. The easiest way is to say, well, the derivative with respect to x, the constant's k, so it's going to be out here in front. So this is going to be k f prime of x. Okay, so now this sets us up very nicely, right? We can do just about any polynomial function. Let's try one. How about y equals 5x to the 4th minus 3x squared plus 6x minus 7? Can we take the derivative of that function? Well, we sure can. That would be y prime. And remember, we can express y prime as dy dx. 20x cubed minus 6x plus 6. What about the 7? Oh, the derivative of -7, that's 0. So now we can take these derivatives of a nice polynomial function. Well, what else do we know? Well, we know our trig derivatives. Now, these are ones you do have to memorize. So let's get those. We'll call this number 5 our trig derivatives. And again, we can derivatives. We can derive these using our limit definition, and this is what you'll get. And these are ones you're going to need to know. The derivative with respect to x of the sine of x. The derivative with respect to x of the cosine of x. And the derivative with respect to x of the tangent of x. Now, what about the other three? Well, you've got to know those too. Can you see me over here? The derivative with respect to x of the cosecant of x. The derivative with respect to x of the secant of x. And the derivative with respect to x of the cotangent of x. We need to know these 6 derivatives. These are our trig derivatives. Well, here we go. Derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Now, where do these all come from? They come from simplifying this and then using those trig sum and difference formulas from pre-calculus. And then you kind of simplify things, move terms around, look at the graph, and this is what happens. How about cosecant of x? This is negative cosecant x cotangent x. The derivative of secant is secant tangent, and the derivative of cotangent is negative cosecant squared x. Now, these are 6 that you need to know. So if you need to pause the video and write those down, well, now would be a good time to do that. Okay, so these are our general rules. Now, and the power rule is really the big one that we use. And that's for any n, even if n is a fraction. So the derivative of x to the 1/2 would be 1/2 x to the 1/2 minus 1, negative 1/2. All right, let's take a look at 2 big rules then that follow. Okay, number 6, we call the product rule. And the product rule says, if you have y equals f of x times g of x, right? 2 functions of x, we have a rule for this. Y prime is going to be the first times the derivative of the second plus the second times the derivative of the first. And then we have the quotient. This one says if you've got y equals f of x over g of x, y prime becomes low d high minus high d low over low squared. And we'll write that as g squared x because that means g of x squared. Okay, so this is a lot of information in a short amount of time. But as you think about this, these are the rules that you need to know in order to be able to differentiate and analyze all kinds of functions. Now, there's a few more derivatives, some exponential and logarithmic and inverse trigs, and we'll get to those, but they're just a few more rules for you to know. And then once we do that, we'll have all of our rules, and then it's really just applications. Okay? Product rule, quotient rule, and then, in my opinion, the power rule. Those are the big 3 that you need to know. How about an example? Let's take the power rule and the quotient rule, and let's do one. So let's say we had f of x is, say, e to the x tangent x. Now, I didn't list e to the x in my rules, but you should know that the derivative of e to the x is e to the x. Okay? In fact, why don't we go ahead and make that our 8th and 9th rule. Sorry, before we get to this example, let's go ahead and do number 8, the derivative with respect to x of e to the x is e to the x. And then number 9 now, the derivative with respect to x of a to the x. Well, it's very similar, a to the x. But then you write natural log a. And again, the proof of this comes right from the limit definition. And they're all over the internet, and I'll be happy to draw up a proof for you. But this is what we have. The derivative of e to the x is also e to the x natural log e, but what's the natural log of e? Okay, so here's rules 8 and 9. Okay, now let's take a look at an example. Let's do f of x is e to the x tangent x. So here's our product rule, and let's see how this works. I'm going to go f prime of x. Let's see, first times the derivative of the second. Oh, that was secant squared x. Plus the second tan x times the derivative of the first. Well, the derivative of the first is, what's the derivative of e to the x? E to the x. So there you go. Now you're saying, well, do I need to simplify that a little bit more? Sure. You could e to the x times secant squared x plus tan x. But ultimately, that's just a little algebraic manipulation. The main idea here is, can you do the calculus? Can you do the product rule? Okay, that's a lot of information. Why don't we review? We start with our limit definition. This is f prime of x. This is where it all starts. We then take our derivative rules. The constant, sure, that's a horizontal line. That has a slope of 0. How about the linear function? Yeah, the slope's the coefficient of x. We've been doing that since middle school. Your general power rule, this is the big one. N x to the n minus 1. Your general constant rule. Move your constant out in front. We did a nice example here of a polynomial. You've got your 6 trig derivatives, right? You then have your product rule and your quotient rule, followed by your exponential rules. So here they all are. These are the big ones you need to know. Okay? Exponential rules, product rule, quotient rule. Your trig derivatives. Your general constant rule. General power rule. Linear, constant, limit definition of the derivative. Everything you always want to know about derivatives, but we're afraid to ask. Reference that Woody Allen movie from the mid-70s. Okay, now you're going to practice a bunch of these, and then we're going to move on to chain rule and implicit differentiation. For now, have fun doing calculus.